Welcome to True Projects. In this video, we are going to explain about the project which is DROPS, which means division and replication of data in cloud for optimal performance and security. Introduction of the project. The rapid evolution of the information technology infrastructure has been significantly influenced by the advent of cloud computing. This paradigm, characterized by on-demand self-services, ubiquitous network access, resource pooling, elasticity, and measured services, offers a compelling solution for business, organizations, and individual users seeking cost-effective, flexible, and easily scalable IT solutions. Despite the benefits of cloud computing, security concerns represent a major obstacle to its widespread adoption. Issues such as virtual machine escape, structured query language injection, and the data recovery vulnerabilities pose serious threat to confidentiality and integrity of the data stored in the cloud. The security of the cloud environment depends on the collective security measures of all participating entities, making it crucial to address vulnerabilities comprehensively. The project introduces the division and replication of data in the cloud for optimal performance and security, which means DROPS. This methodology has a novel approach to address both security and performance challenges in cloud systems. DROPS strategically fragments user files into secure, non-meaningful pieces and replicates them across multiple cloud nodes, employing concepts such as decoloring and centrality measures to enhance security and retrieval efficiency. The primary objective of the DROPS methodology including minimizing the risk of data compromise by ensuring that even if one node is compromised, only a fraction of the data is accessible. Additionally, the methodology aims to improve data retrieval time and overall system performance without relying on computationally intensive security algorithms like AES or DES. Objective of the project. The primary objective is to bolster security in cloud computing by strategically fragmenting user files. This minimizes the risk of data compromise, ensuring that even if one node is compromised, only a fraction of data is accessible. The project aims to enhance data retrieval time within cloud systems by employing centrality measures. The methodology seeks to optimize the access time for improved overall system performance. Unlike traditional approaches relying on computationally intensive security algorithms like AES or DES, the project focuses on achieving security through intelligent file fragmentation and strategic replication, thereby improving performance without scarifying security. The project aims to create file fragments in such a way that they do not contain meaningful information individually. This unpredictability adds an additional layer of security, making it challenging for an attacker to derive meaningful data from compromised fragments. To implement this project, we need software and hardware requirements. So the hardware requirements are operating system of Windows, processor of i5 and above, RAM of 4 GB and above, and hard disk of 20 GB and above. Coming to software requirements, we need application of Python ideally, primary language of Python, front-end framework of Tkinter. To execute this project, we have designed various modules in the methodology. So the first module is sign up. This module is responsible for user registration. User input their information such as username and the password, etc. to create an account. The next module is login. This module handles user authentication. User input their credentials, which are the username and the password, to log in. The system checks the entered credentials against the stored user data to grant or deny the access. The next module is uploaded file and generate fragments. User can upload a file through this module. The uploaded file is then divided into fragments or blocks. The fragments are assigned unique identifiers and stored in different locations, which are cloud servers, for security and performance reasons. The next module is replace fragments. This module is related to the replication or replacement of the fragments. It involves ensuring that each fragment is stored on multiple cloud servers for redundancy and security. The next module is download fragments. User can download a file through this module. The system retrieves the required fragment from the cloud server and reconstructs the original file for the user to download. The next module is RC versus file fragments graph. This module appears to generate a graph compared the proposed drop approach with an existing greedy algorithm. To execute this project, first we need to open the code folder which contains source code files. So this is the code folder of the project and this is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. And this is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the Python main code file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the run.bat file. Instead of executing the project through command line interface, we have created this run.bat file, which is Windows batch file. Here we have Cloud Server Run folder 2 and 3. If we open the Cloud Server Run, we have one Python main code file and the run.bat file. Similarly, in other two Cloud Server folders. So to execute the project, first we need to open the Cloud Server Run folder and double click on run.bat file. So here, Cloud Server Run has started. Now minimize it. And we need to run Cloud Server 2. For that, we need to open Cloud Server 2 folder and then double click on run.bat file. Cloud Server 2 has also started. Now minimize this also. And then open Cloud Server 3 and double click on run.bat file. Here, Cloud Server 3 has also started. Minimize it. Get back to the main directory and double click on run.bat file. Flash server will host the application locally at the default address, which is the localhost and the port, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. I'm copying the link. Here we need to paste the link. At the end, we need to type index and then click on enter. So here we can see the web page of the project is displayed in the browser, and this web page is built by using the Flash framework. Here we can see two links, which are login here link and sign up here link. First we need to click on sign up here link to add the users. Here we need to enter all the user details. So first we will give the username. So the username is Kiran. Password of the user. Phone number of the user. Email ID. Address. And gender we need to select as male and then click on register. Here we entered wrong phone number, so we will enter it again. Now we will click on register again. So here we can see that sign up process is completed. Now we need to log in as user. For that we need to click on login here link. Here we need to provide credentials of the user, which are the username and the password. So I am giving the username and the password. And now we need to click on login. User has logged in successfully, and here we can see various links, which are upload file and generate fragments, replicate fragments, download fragments, RC versus file fragments graph, and logout. So first we need to click on upload file and generate fragments link to upload the file. Here we need to click on choose file and then select any file. So I'm selecting this file, and now we need to click on open and then click on submit. Here we can see that the file has been uploaded and total 10 fragments are generated. Now we need to click on replicate fragments link to send all fragments to 3 cloud servers. Here we can see all the 10 fragments, file name, block name, and saved location where the fragment is stored. Now we will open the cloud server 1, users. We have uploaded this file, so we will open it. Here we can see that 4 blocks are saved from that file. Remaining blocks will be saved at Cloud Server 2 and 3. Now we will get back to the user interface. Now we need to click on download fragments link. Here we can see a drop down. From that we need to select the file. So I'm selecting this file, and now we need to click on download. So here we can see that file is downloaded in the C directory. Now we need to click on RC versus file fragment graph. Here we can see that on x-axis it represents names, and on y-axis it represents block saving time. And drop is the proposed work which took less time compared to existing greedy algorithm. Drop will save storage time by sending blocks, replications to multiple servers. So here in this file we can see that this file has been downloaded. Conclusion of the project. Our methodology adeptly balances security and performance in cloud computing, showcasing the potential for robust security without compromising system efficiency. Shifting from traditional reliance on intensive security algorithms, our approach prioritizes intelligent file fragmentation, enhancing security while streamlining the cloud environment. The adaptability of the division and replication of data in the cloud for optimal performance and security methodology, which is DROPS, across diverse architecture positions, it has pragmatic solution for the complexities of modern cloud environments. In the conclusion, we recognize the methodology's significance and its applicability in evolving cloud technologies for continued advancements in seamlessly integrating security and the performance.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.